All right. So with that, I want to introduce Shaun. So as I mentioned, we had a event last year with Kat and on ROS, and she had recommended talking to Shaun about ROS Industrial because we have quite a few folks who are working on industrial use cases. Um, this is part of our open source series. So we've been, over the past few weeks, we've been hosting a series of meetups, essentially looking at the different open source projects that are out there that touch IoT and industrial IoT. And we've had a few folks from LF Edge. We'll be scheduling a few meetups from the Eclipse Foundation as well to look at what projects they have under them. And today we're going to talk about robotics. So before we get going, Shaun, maybe you can tell us a little bit about yourself. Shaun is in Texas. Fortunately, he has power, but it sounds like no water. But maybe you can just give us some background, and we can get going.
Sure. Thanks again, Hans, for the invite. I'm really excited to give this talk to such a broad audience, and I also appreciate this platform. It makes these COVID times when we can't network. It makes it I'll say tolerable. So I really appreciate that. So yeah, my name is Shaun Edwards. Currently, I'm a co-founder and CTO of +1 Robotics. It's a robotics startup here in San Antonio, and I will I'll go into some detail on what +1 Robotics does. But what I do is I do our main product development. So I head up our main product development, and as you might guess, it utilizes ROS. ROS is very important to us. Prior to starting a company, I worked at a place called Southwest Research Institute, which is a not-for-profit applied R&D institution. And I was lucky enough to work on robotics and manufacturing there. I worked on some of the largest robots in the world. The robots that I worked on stripped paint off of various kinds of aircraft. So robots as big as buildings, essentially. While I was there, I had the chance to found ROS-Industrial, which is what I'm going to talk to you guys about. And then before that, I graduated from Case Western Reserve University in Cleveland, Ohio, with a master's in mechanical engineering, although my entire career has been programming. So that's it. That's me in a nutshell.
All right, cool. So if you wanna get going, and I'll remind folks, if you can just fill out the survey form. I just pasted it in chat again, and we'll look at the results when Shaun gets to that portion. Thanks, Shaun.
Thank you. So there we go. All right, let's get going. So the title of today's talk is ROS-Industrial, the open source industrial robotics operating system. For those of you that watch Kat's talk, I'm going to try. The purpose of my talk is really to differentiate from, what is ROS versus ROS-Industrial. What were the motivations for creating it? Why I thought it was needed, and what we've accomplished. And then because this is an IoT group, I thought normally I would stop there, and I wouldn't even talk about +1 Robotics, honestly. But I think the cool thing about this group is that you understand the cloud and you understand the Internet of Things, and +1 is kind of the robotic incarnation of the Internet of Things. So So I'm going to talk a little bit about Plus One, but I'm going to focus on how it relates to the Internet of Things, and how we bridge that gap between ROS and the Internet of Things. All right, so just quick agenda. I'm going to have a little bit of fun to start off. We'll do what I'm calling a lesson in engineering, but I'll talk a little bit about that. We'll do some audience participation. I love getting to know my audience. I love kind of tailoring discussions towards what my audience cares about. So I always like the opportunity to get to know you guys. So please respond to that survey so that I can do that. We'll talk about ROS Industrial. We'll talk a little bit about Plus One Robotics, and then when I have amazing people in the room, I always like to end with a call to action, and so that's what I'll do here. Okay, so I am based here in San Antonio. I don't know how many people in the room here, the virtual room, are within Texas, but you might have heard that we're dealing with kind of a weather event down here. It snowed in San Antonio, which, if you're not familiar with the geography, San Antonio is closer to Mexico than any other U.S. state. So we're pretty far south, and I've lived here 15 plus years, and it's only snowed the morning of the first snow. I went out and I took this picture outside my house. And I thought, man, isn't this beautiful? It hasn't snowed like this in 30 years in San Antonio. So we likely won't see this again. But as you've probably been hearing on the news, things have not gone well. And it's an interesting case study. So I just wanted to bring it up. And hopefully you guys find this interesting as well, and maybe just get a perspective from somebody who's living through this. So on Monday, it snowed. We had low temperatures, which resulted in a significant increase in demand for electricity. At some point, the grid stability was threatened, and so they called them rolling blackouts, but they cut off 2/3 of customers in San Antonio, right? So they turned off the electricity, and that caused basically a loss of heat. Nobody was able to heat their homes anymore, and our pipes, which aren't insulated, started to freeze. So combined with that, we lost a bunch of electricity. We have, that resulted in pump failures in the water system, and then a loss of water pressure. So that was basically yesterday, and basically a citywide disruption of water services. So at that point, basically you have no water, you have no electricity, and this is the boat that 2/3 of the people in San Antonio are in. I'm lucky enough that I'm on a critical circuit for electricity, so we didn't lose electricity. But today and tomorrow, what we're going through is increasing temperatures that are reducing our electricity demand. So the grid is now recovering. The pumps are restarting and beginning to pressurize the water system. And in the next couple of days, what will happen is that the frozen pipes, which are technically broken right now, they're going to pressurize and they're going to start leaking a lot of water. And this is going to be a significant property damage event, like on the scale of hurricanes. So I don't think many people, if anybody, could really have predicted like this cascade of events. But I thought I'd bring it up with this group because this group is certainly technical. And one of the things that I like to think about is at +1 is quality assurance. And I always tell my QA engineers that, let's not focus on the happy path. Let's think about the corner cases. Let's figure out how our product can fail. And so I see this systemic failure that we kind of went through in Texas as a failure of QA. Somebody didn't think of the corner case, or at least hadn't thought to test it enough to kind of expose this fragility within the system. So anyway, I wanted to talk a little bit about that. There are certainly people in San Antonio for whom this is a huge disruption, and there's been significant problems. So that by no means do I want to make light of the situation. Engineering is really important, and this is an example of when engineering gets it wrong, and people's livelihoods and even lives themselves are impacted. So I thought I would share this with you guys before we got started, because honestly, it's been a rough week. So I thought sharing would help. So, and with that, we will. It looks like we have one question, Hans. I don't know if we want to handle it. If it's related to this, I'm happy to answer it now.
Yeah, I think that was just me letting people know.
Okay.
Ask the question. So yeah, you can carry on.
Okay. All right. So, all right, Hans. Now on to our audience participation.
Okay. So I can share the screen. Let me share the screen here. Actually, let me just read them out so we can carry on. So what's your interest in robotics? So we have almost 47% are robotics professionals. 13% are hobbyists. 40% are just curious. Next one, for robotics professionals, do you work with IoT devices that change their environment? Wow, 83% say yes, and the rest of them are saying no. Next question, are you interested in being part of a ROS-I global community to change the world with open source software? 73% say yes, and the rest say maybe. There's no answers that say no. That's cool. And then I'll just read out some of the responses from why are you considering ROS-Industrial. I see your response. I created it. So interesting one. So there's quite a few people who are learning. I have somebody who's saying I've been following it for a while, interested in 3D synthetic data and digital twin. Another one, interested in finding out what is specific to Robotics OS, say in comparison to RTOS. And then, I'm interested in IoT and IoT in general, and think robotics are a big part of this movement. And somebody says, I'm not considering ROS-Industrial. Yeah, that's it. Yeah, and quite a few people are just here to learn. So those are the responses.
Awesome. Well, thanks so much for taking the time to fill that out, guys.
Thank you.
So I'm glad to hear that there's a fair amount of roboticists here. We're a small community in the world, so it's always great to get together. Normally when I talk to an IoT group and I ask the question, like, can your devices change their environment? A lot of people just think of IoT as sensing. And I think the cool thing about robotics is that it's an IoT device that can change the environment, that can actually do stuff. So after this talk, I'll be curious to hear kind of what others are doing, robotics related or not, that IoT devices that change the environment. And I'm glad to hear there's interest in being part of a global community. But honestly, the way I put it, how can anybody disagree? Who doesn't want to change the world through open source? But I'm happy to hear that you guys are interested in that. Okay, so I'm gonna kind of jump into my talk on ROS-Industrial, but I want to caveat up front. ROS in kind of open source in general, there are a lot of people who do a lot of good work to make all this stuff possible. And so everything I'm going to present, none of it would have been possible without those contributors to open source. And what I did was just a small piece of it, and it wouldn't have been anything if not for the people that found ROS-Industrial or ROS in general valuable and did their part to develop technology and promote its use. So I really do feel like I'm standing on the shoulder of giants, and I just want to recognize that. Okay, so I'm not going to go deep into ROS in particular. Certainly, Kat Scott did that back in November. That's a great talk to go through. I actually watched it yesterday. But I do kind of want to point out the impact of ROS. And the top sentence kind of says it all. It is impossible to overstate the impact that ROS has had on robotics. It can't be overstated. I'm going to give you some examples of that. But it was completely, it disrupted robotics as it had been done before. And I will point out, when I show this slide, a lot of people are like, well, I knew something back in the 90s that did, that thing that you said only ROS does. So I put up in the title that with each of these, I'm implying that most, right? Most software didn't do this, and most software didn't do that, and ROS changed that. ROS was released in 2010. 11 years ago, 10 years ago. Before that, robotic software was built entirely from scratch. It was limited in capabilities. It had limited tools. And it was a Herculean effort. After ROS, it is honestly very hard to find people who aren't building robotic software on top of ROS. There are some. There's a very big company that I'm sure that this group in particular might be familiar with that doesn't utilize ROS like others. But when it comes to startups and research labs and everywhere else, software is built on top of ROS, robotic software in particular. So before 2010, before ROS, if you were in a lab or a company, you would utilize a completely homegrown framework or architecture. And now, again, most everybody utilizes ROS at a framework and an architecture level. Before ROS, we programmed robots in C and C++. It needed to be close to the metal. It needed to be fast. It just had high performance requirements. So now when you post a job, and this includes the jobs that I post for my company, robotics, ROS is required, right? ROS supports JavaScript, Java. There's all kinds of implementations of it, C++, Python, but we basically say ROS. That's what you need to know. Before ROS, software was expensive, especially in the industrial space. Tens of thousands of dollars for anything kind of labeled robotics and in kind of industrial grade. After ROS, software is still expensive. So ROS didn't drive down the cost of software, but now ROS is this open source option. And what you are seeing is broader use of robotic software. So the people who were paying for it in the past, a lot of those people still pay for it, but a lot of new people in this space are just using ROS to start. Software was a barrier to entry before ROS. Now startups roll out MVPs in a matter of months that are built on ROS. So that's really enabling. As I started a robotics company, and I cannot imagine trying to do it without ROS. I wouldn't have started. So it really was an enabler for us. Before ROS, open source robotic software was ridiculed. There were certainly robotics projects before ROS, some of them pretty good actually. But from industry, they didn't understand open source. They felt like it didn't, it wasn't capable, it wasn't robust. They saw very little value in it. And now, ROS is accepted. ROS in the latest version, ROS-II, are considered for high reliability applications, things like autonomous driving, things like industrial applications. So, I would guess that a lot of people in this room think about open source in this, really long life on the internet and broad adoption of web technologies that are open source. With robotics, it was really ROS that powered that. And then finally, before ROS, the robotics community, and I'm talking basically on the technical side, was really limited to academics. Get together at a robotics conference, talk about the papers you wrote, not much sharing of software, but certainly sharing of information. And what ROS did, right? If ROS, I'll make this claim that if ROS didn't do this, it wouldn't be as important as it is today. ROS created this community, and industry started to embrace this community. And it's the community, the scale of the community, it's global, it's worldwide, it's all the top research universities and R&D institutions in the world. That community is what makes ROS better than anything that came before it, and better than anything they've tried in the last 10 years. And I'm not sure how many of those there were, but none of them have stuck around. So so when we talk about ROS, this is the impact that it had. All right, so I'm going to talk, so I'm not going to talk in detail about ROS, but I will encourage you to look at Kat Scott's presentation. And it's really good. She went into great detail, and now I'm just kind of go into what is ROS-Industrial. So the first question that a lot of people want to know is like, well, why did ROS-Industrial ever become a thing? How did it start? So I'd love to tell you that when I saw ROS, when it was released as 1.0 in January 2010, so Willow Garage was the company that created ROS. That's the date that they released it. They started, they made this big announcement. I saw this announcement, as did many others, and I honestly discounted it because I looked at it and said, well, there have been open source attempts at robotic software in the past, and none of them have really taken hold. And this is, I'll be honest, I thought it was something that was doomed to fail. But over the course of several months, experimenting with it at my job at Southwest Research, by March, we were using it to do some proof of concept experimental things in the industrial robotic space, and also autonomous driving. We were one of the earliest users of ROS for autonomous vehicles. And this is back when it was ROS-I and nobody thought it was reliable enough. So as part of that effort, or that use of using ROS at Southwest Research Institute, I realized that, hey, if we just made it easier for ROS to work with the industrial platforms, you know, that would be pretty powerful. I didn't realize the true magnitude of the power of it. In my mind, I was really just scratching an itch, right? And that's how a lot of good open source projects get started. I wanted to make it easy to use ROS to run these industrial platforms, so that, you know, that meant creating a lot of drivers and kind of low-level software to connect ROS to the industrial platforms. But the reason I did it is the tools and the libraries and the development environments for industrial robotics and industrial platforms like PLCs is awful, incredibly awful. Now, I have an appreciation today for how robust and simple they are, but I was young enough then that I just was frustrated and felt like there had to be a better way. And so that's what I did. So I went to Willow Garage as a visiting researcher, and I started committing to what would become the ROS-Industrial software repository. The first robot to run ROS, and what became ROS-Industrial, was Motoman, and that was in December of 2011. So you can see that's nearly 2 years after ROS actually came out, and that was kind of the first connection between ROS and an industrial robot. And being a software engineer, I wanted to prove that I could control any robot with ROS. I, you know, shortly thereafter in January showed running an industrial, another industrial arm, the Adept arm, on ROS-Industrial. And now I'm going to switch to what I admit is a very embarrassing video, but I want to give you an idea of in December, January timeframe, 2012, what we accomplished, and then I'll talk about why that was really important. All right, this should share with audio. And the first 30 seconds, really embarrassing, but after that, I think it'll be meaningful.
Hi, my name is Shaun Edwards, and I'm a guest researcher at Willow Garage. I'd like to take this opportunity to announce the ROS-Industrial software repository. The main goal of ROS-Industrial is to integrate ROS with an industrial robotic platform. Take a look at what we've done so far. I'd like to thank our research collaborators, Southwest Research Institute, Willow Garage, and Motoman Robotics. For more information, check out the link at the end of the video.
All right. So back to the presentation. So what you saw was, oops, sorry. Okay. Sorry about that. The video kept playing. So what you saw was the first, ROS controlled industrial robot. And what I didn't appreciate at the time, because ROS had been around for 2 years, we were using it to drive autonomous vehicles. And so the power of ROS to me was very apparent. What I didn't appreciate was that nobody could connect the dots if they didn't see it running on their hardware. So while what you see in that video, me controlling an industrial robot with ROS, is not technically very impressive, it got a lot of people excited because all of a sudden they're like, they could connect those dots. I will say that that's a lesson that I learned then and I continue to utilize today. Connecting the dots for people was really, really important, and it was really important to the ultimate success of ROS-Industrial. Okay, so if that's kind of where we started, where are we today with ROS-Industrial? So we have a fair number of roboticists in the audience, so I don't want to belabor this point. But real quickly, I want to kind of inform others that industrial robots are really, really dumb. They're not very intelligent. Very rarely do we ever put cameras on them. Very rarely are their motions very dynamic. When you look at an automotive application where robots are predominantly used these days, nearly all of those applications are blind robots just repeating the same paths over and over and over again. And so I used to tell people that industrial robots are really just really smart and accurate motion controllers. Clearly things are changing. I mean, we started ROS-Industrial 10 years ago, so I'm going to talk about how things are getting better. But I think it's helpful to understand the states and the predominant use of industrial robotics in order to understand why some of the things I'm going to talk about today are incredibly are impressive and what really enable advanced applications of robotics, like the ones we do at +1. So first I'll talk about kind of enabled capabilities. So I talked about robots being blind and just, doing the same path over and over again. So with ROS and then ROS-Industrial, what we've been able to do is give robots the ability to make dynamic path planning decisions, move using information sensed from the environment, move in a collision-free way, or on the fly adjust your path to account for something else going on in the environment. So that's a capability that's built within ROS and enabled by ROS-Industrial. Advanced 2D and 3D processing. There are powerful libraries for 2D and 3D processing. There are powerful sensors today that can feed into those libraries, but there isn't a kind of industrial framework that brought all that stuff together and allowed end users or programmers the ability to leverage all of that power. Something ROS-Industrial did is it connected, these advanced sensors to industrial platforms, and then it allowed programmers the ability to leverage really high-powered libraries to interpret that 2D and 3D data and make decisions for the robot. And that just wasn't how it's done. And even in a traditional automotive application, a lot of that 2D and 3D processing is hidden away and and simplified on the camera. So while it's valuable in being simple, it doesn't allow for advanced capabilities like ROS-Industrial. Item recognition and registration. So being able to, robots interact with different parts in the environment, but in order to do that, you have to recognize the parts, and you have to identify where they are relative to the robot. Again, those powerful libraries within ROS, ROS-Industrial, and open source in general really allow you to do more than you can do with kind of off-the-shelf industrial software that you pay for. Modern UIs. This is a little bit of a pet peeve of mine, but if you've ever looked at an industrial device and you look at the user interface, your immediate gut reaction is, oh, that must have been programmed 10 years ago, or even longer sometimes, because the UIs make them look very dated. And honestly, I don't know why that is. But I know that through ROS and ROS-Industrial, you get access to modern UI libraries, which allow you to create modern feeling GUIs that interact with these industrial platforms. And the benefit of that is all the UI stuff that has gone in to make our phones, to make websites more usable. We get to leverage all of that through ROS-Industrial. I talked about state-of-the-art libraries, modern developer tools. This may seem a bit crazy, but as little as 5 or 10 years ago, the development tool for some industrial robot platforms was Notepad. And so you can see we're having modern developer tools, autocomplete, debuggers, that kind of thing can be very enabling from a developer standpoint. And then finally, one of the other kind of advanced capabilities that came with ROS was the tool RViz, which is really just a really impressive data visualization tool. And I like to tell people with ROS and ROS-Industrial and RViz in particular, you can see what your robot is thinking, right? So there's tremendous value in being able to see the sensor data in the same kind of 3D environment as you see your robot and all the other things going on. I had a project at Southwest Research Institute, and it was basically a redo of a past project. And in the past project, we were scanning items, and so there were multiple LiDAR scanners connected to a PLC. And I don't know how many people have used PLCs. They're not that capable, and they're kind of a pain to use, right? So that project was never successful. We could never get the scans working correctly, and we had no way to debug the system when it wasn't working correctly. So just porting this application to ROS and routing all the LiDAR scan data through ROS into RViz, that immediately allowed us to debug the system, make it better, understand while it was failing. It was a tremendous improvement, and all we did is change the tools that we were using. So while visualization may not seem that valuable, it's incredibly empowering from a developer standpoint. So those are the capabilities that are kind of enabled by ROS and ROS-Industrial. With ROS-Industrial in particular, what we were focused on a lot was, okay, what can we do with these applications? What can we do using ROS-Industrial that nobody can do today, that nobody can buy off-the-shelf hardware or off-the-shelf software to do and deploy, on the factory floor, for example. And so one of the applications, or kind of a group of applications that we talk about, is scan and plan. And I'll show you a video that goes into more detail about scan and plan. But the idea is that you have some process, painting, grinding, welding, whatever it is, you want to do that on an arbitrary part. And so you need to scan that part, you need to recognize that part, you got to localize that part, you got to evaluate the surface of that part. You then have to plan the robot trajectory. All of those capabilities are the ones from the list above. So it really enabled robots to go from, an automotive application where it does the same path no matter what, no matter, if the car frame shows up in the same position or not, the robot's going to do the same thing. It really made this truly dynamic application called scan and plan possible. Autonomous mobile robots, or AMRs. That's another kind of area that's outside of my area of expertise, honestly, but has since exploded with in the space that we're in, logistics, with broad adoption of AMRs, and the vast majority of them run ROS underneath. And then vision-guided manipulation, which is what +1 Robotics does, is essentially being able to sense your environment and then intelligently manipulate the items in that environment. So that's something that was not easy before ROS and ROS-Industrial, and it's something enabled by the capabilities above. And finally, I want to talk about the ecosystem. I talked about how important the ecosystem was for ROS and how that made it different from everything that came before it. And I feel the same way about ROS-Industrial, right? By looking at ROS, we understood the value of an ecosystem, and so we made it our mission to create an ecosystem. And I'll talk a little bit more about the ecosystem in the next slide. But it brought together industrial R&D labs, tens, if not hundreds of startups that are working in the industrial space. And it built upon the ROS global open source community. So we created this incredible ecosystem that understood the value of ROS and understood, hey, we can take this incredible technology, the capabilities, and we can enable applications that we haven't been able to do before. And so, that's tremendous. So the example I'm going to show you kind of shows a lot of these technologies pulled together in kind of one application. And this is not something that I've done. This is something that Southwest Research Institute has done with Spirit AeroSystems through the ARM Institute, which is the funding body for robotics research. But it's certainly built upon ROS and ROS-Industrial, and the cool thing about it is how many of these capabilities that is brought together into one application. So I'm going to switch videos. Share audio. And there you go. All right, I'm gonna play this one through. It's a little bit long, so I'll skip around and kind of show you some things, and then I'll talk a little bit about what's there.
Shaun, is there supposed to be sound?
Oh,
yeah.
Actually, there isn't sound, but I can talk through it. It just makes sense.
All
right. Thanks, Hans. So what you're seeing is the system sensed the part, it scanned the part, it localized the part, and then it planned a sanding path across this part. And it's doing all this purely on sensed information. So this particular application is something people do by hand today. At Spirit AeroSystems, there are people who hand sand airframe components. It's not a fun job. But because it involves kind of perception and kind of a sense of touch and some level of intelligence, it is not one that's been easily automated. And so you can see that the robot is kind of moving around. It's following that surface plan that you saw in the previous part. It's now going to switch an end effector. Let's skip through this part because it's less interesting. So it sands it. A person comes in, and this is really neat. A person comes in and marks up the parts that the robot needs to fix. And the system scans the part again. It sees the markings that the person put on there. It identifies those, and then it goes back and it reworks the things that it has to fix. So I think this is, really cool technology. It takes a really, ergonomically bad job and allows robots to do it. But it still recognizes the value of people in this particular process and being able to identify, rework and that kind of thing. So there we go. Switch back to the presentation. Okay, so in that one video, that was a scan and plan application, and you saw all of these enabled capabilities. You saw all of them brought to bear on that one application. So that one video, when you compare it to that first video, that's the progress we've made in 10 years, and that's the things that we're enabling. What's cool about this, the scan and plan technology, by the way, there are probably a handful of startups that are taking this core tech and they're productizing it and they're bringing it to markets. And, this will be available. And, if not today, but in the very near future, we can say, hey, the scan and plan technology is now available just off the shelf, which is really what we wanted to do with ROS-Industrial in the first place. It wasn't about replacing any one technology. It was just making these advanced applications available. Okay, so one thing I do want to talk about is I talked about the ROS-Industrial ecosystem, and I know people are interested in how to participate in the ecosystem. So when we started ROS-Industrial, we believed that it needed industry input, it needed industry support. So one of the things we did is we created a consortium at Southwest Research Institute called the ROS-Industrial Consortium, and because we're engineers and that was a great name. So we started that, and then we found partners around the world in Fraunhofer IPA in Germany, and then another research institute called A-STAR in Singapore. We partnered with them to create this global organization of consortia and bring manufacturers and users, equipment providers together to support ROS-Industrial and make it self-sustaining, but also provide input. So that's what you see there on the right, is the kind of extensive list of companies that now support ROS-Industrial and really enabled all the capabilities we talked about in the prior slide. So with that, that's kind of a high-level overview of ROS-Industrial and the things we can do with it, but I'm happy to answer any questions that people might have.
Yeah, so hang on. Yi has a question. I'm going to bring him on stage. Hi, Yi. Go ahead. You there? All right, I'll come back to you. Oh, both the questions are his. Okay, I can ask the question. So the first one is, what's the most challenging part of that sanding example? Is it the vision on being able to detect anomalies or something else?
So the vision part is challenging in kind of dealing with the reflectivity of the parts and the kind of inaccuracies in vision sensing. But honestly, there's a lot of powerful tools to bring to bear there. So a lot of those things have gotten easy. The part that you might have noticed that I struggled with was the path planning part of it. And so today it's because robots used to just do repeated paths, there wasn't a lot of emphasis put on intelligent, fast, collision-aware path planning. So that's still a little bit of a hard problem. There are people around this world who actually know how to solve it, right? And if you could bring together the right team, you could really finish it out. And honestly, that's what the companies that are doing this, that's what they've done, right? They've started where Southwest Research and Spirit Aerosystems left off, and they've really tightened down those two things. But it is still a hard problem on the perception and the path planning side.
Cool.
Thank you. That's helpful.
Oh, all right. Do you want to ask you a second question, and then there's another one from Sanjeev. So.
Yeah, sure. So I'm assuming you guys can hear me now. I think I see my mic moving. Okay, good. For the open standard that you guys are have developed around ROS, are there competing sort of open standards that are out there that companies that play in this field, including the large corporates, or is it ROS? Is it kind of the one and only? Because there's obviously a huge benefit to having that. We've seen it in IoT and across a number of other industries as well. Yeah,
so I will, this leads to some of the things we do at +1 Robotics, but, this idea of kind of network communications between devices, connecting cameras and robots, a lot of that stuff is not new. And in industry, we were doing it, we've been doing it for years, like literally decades of networked I/O. The difference was that what ROS brought to the table is it gave kind of semantic meaning to what things were. So it basically said, if you have a camera, every camera will look like this. It will produce this information, this message set. So ROS enforced that, which that made it valuable. That made it interchangeable, which is something that networked I/O in the industrial space kind of struggled with. But the other thing it did is ROS brought tremendous capabilities to bear. So it's kind of the de facto standard, because you're like, well, I could use a different standard, but then I would have to worry about how to read that and deal with it and incorporate all the powerful capabilities of ROS. Or I could just use the ROS messaging standard and use the capabilities within ROS natively. So, that is the power of ROS, but it's localized. It doesn't go much outside the robotic cell, and that's something we've learned at +1. So when we talk about ROS, it's very much, how does a robot talk to a camera? How does a robot talk to a particular sensor? But as far as IoT, it's not quite it's not quite there.
Yeah. So
thank you. Thanks, Hans.
Thanks, Pete. Can I take another question? Actually, I think this one is from Sanjeev, and it's kind of related to what Yi was just asking. I'll bring Sanjeev.
Hey, Hans, can you hear me?
Hey, Sanjeev, how's it going? Go ahead.
Good. Hey, thanks. So, Shaun, very good presentation. Quick question. From what I understand, some of the larger robot makers who have big installations in auto manufacturing and such tend to have sort of closed systems. And I'm wondering if there are initiatives to open those up and let them talk to source applications like what you might build with ROS.
Yeah. So when we started, first I have to give the industrial robot companies a tremendous amount of credit. Their devices are extremely reliable. They're safety rated. They're very robust. They run hours and hours, and they don't crash. So there's a lot of valuable capability just built into a robot controller. When we started, robots, people generally felt the way you do, Sanjeev, which is, hey, they're so locked down, I can't get in and do what I want to do. So I actually had a tremendous amount of experience of reverse engineering a few of these things. So I was able to drive motion directly from ROS. And that's what you saw in that video. Believe it or not, a lot of people at those companies were amazed that I could make that happen. It wasn't high performance by any stretch of the imagination, but it proves a point that it could be done. And so 10 years ago, that's kind of where we were. And in the meantime, companies have opened up kind of their motion interface, right, to allow you to drive motion externally. And they utilized a lot of the ideas that we had come up with in the ROS-Industrial community to do that. So today, you can more or less drive motion from an external system, but it's by no means a real-time interface, right? You can maybe do an 8 millisecond update rate is the fastest. And I'm actually happy with the way that is, because any faster than that, and you would start to subvert the safety systems that are built into these robot controllers. And then they become unusable, because as soon as you do that, no factory is going to let you deploy it in their facilities. So I'm pretty pragmatic. I think we pushed the envelope. We got 80% of what we needed, and beyond that, it's a huge lift to take on that safety burden.
Cool.
Thanks. No, thank you.
All right. Thanks, Sanjeev. So we have a couple more folks. Do you want to take the question now, or do you want to carry on? And then we'll get back to questions.
Let me carry on. I know we're going to run short of time, but I'll stick around to be able to answer questions too.
Okay. All right. Just hang in there, Michael and Milan. Okay.
So I was incredibly excited to get in front of this group because one of the things that I think is important is that manufacturing and industry benefits tremendously when larger communities or larger applications develop technology that it can then use. So a really good example is a personal computer. It is used all over manufacturing, but it was developed for another purpose, right? It was developed for a much bigger market. It could be more usable. It was a big enough market that it could drive innovation. The thing about manufacturing, even though it's a very big market, is it doesn't really drive innovation. So we have to look elsewhere for innovative products and then figure out how to use those in manufacturing. And I think IoT is exactly that. And at the end of the talk, I'll talk a little bit more about that. But that's why I'm excited to talk to you. I'm going to show you what +1 Robotics does and give you an idea, because we developed what I believe is an IoT system, but we developed it from the standpoint of roboticists. So I'm really excited to share with you guys, and I'm really excited to hear your feedback, good and bad. But first, I'm going to give you an overview of what we do as a company. And this will have sound. So there we go.
She hires people to fulfill orders for her e-commerce company. But her workers quit after only a few weeks because their work is repetitive and boring. Production is running at full capacity, but there are fewer mispicks, and she can focus her staff on more challenging jobs. Plus One Robotics AI software is smart, not just because it perceives the world in 3D, but because it's also connected to a crew chief, a live human being who can help out when unusual things happen. This robot is confused. This doesn't look like the order. Human to the rescue! Tim, the crew chief, fixes the exception, updates the missing inventory, and the robot is back in action. Jamie doesn't concern herself with these details because Plus One Robotics maintains this service 24/7. Tim can supervise robots located anywhere. Tim stays engaged, constantly monitoring the performance of his robots and teaching them to recognize new items. Jamie, she's just been promoted.
So that's kind of what Plus One Robotics does in a nutshell. And then what I hope you find interesting is that our robots are IoT devices, right? They're connected to the cloud. They send data back to Plus One. And when problems occur, people at Plus One's headquarters here in San Antonio can help the robots out. They can get them running again. And so that's what I meant when I asked the question, how many of you, where your IoT devices actually change their environment? That's what we do at Plus One. Our robots change the environment, and and sometimes they change the environment at the direction of people. So, real quick to talk about our product offering. This is really to facilitate an architecture discussion, not to sell you on our products, but we have two products. Pick one, which is the Edge AI device, the vision system that attaches to all these different robots and enables all these different applications. And then our cloud application called Yonder. And like I said, it basically is connectivity for all these robots doing all these different jobs. It captures a lot of data, and then it allows us to remotely intervene when the robots need help. So that's our kind of architecture in a whole. Here's kind of a detailed architecture of what this looks like. So in the lower part here, that's our Edge application, and this upper layer is our cloud or our web layer. So the thing I wanted to point out here is we don't use ROS at these higher layers, right? We utilize web protocols at these higher layers. And so that means there's always a translator between ROS and some other protocol. And in this case, we use GraphQL. But that's that's the translation component that has to happen. And then once we get there, we leverage all that is GraphQL and Docker and React and Kubernetes and a bunch of other of these web-based technologies that I doubt anybody ever thought they would use to connect to an industrial robot. But through bridging through ROS, we've been able to make that happen. And so like I said, I'm not an IoT person. I know there are IoT protocols and there are IoT capabilities that enable things like you saw in that video. We took one approach to it. What I'm excited about, what I want to talk to people about, potentially after the talk is, how would an IoT person do this? What does an IoT person see for this application? So I'm excited about that. And so if anybody has questions on that, we can take that, and then I'll get to my last slide, which is just the call to action.
So, all right, Michael, I'm going to bring you onto stage. Oh, okay. Looks like he's connected from a mobile device. We'll ask the question. Unfortunately, it doesn't work from mobile.
Oh.
Yeah. So, who do you expect to be using ROS Industrial? Integrators doing one-off builds, product companies selling a technology, in-house automation departments, all of them?
Okay. So I can tell you that all of them do use ROS Industrial, but realistically, I think that the best user of ROS Industrial are product-based companies. ROS and ROS Industrial are extremely complex. It's a heavy lift for integrators, and end users don't actually care how you solve a problem. They just care that you solve a problem. So whether you use ROS or not, or whether they use ROS or not, is really unimportant to them. So I think the product companies are the ones that are going to do this most successfully. And, you know, it's self-serving because I started a product company to do just that. But that's my view.
All right. One more?
Sure.
All right. Hey, Milan. Go ahead.
Hey, Shaun, great presentation, and kudos for actually showing robot sanding, because anybody who's done body work know it's not done visual, it's done by touch and feel, and you actually have to feel what you've sanded to make sure it works right. So that's kind of where my question is coming. We have all these visual cameras and all these visual controls, which is great if you're, let's say, if you're a robot picking weeds out of a garden. But what about the tactile feedback? We don't see that much in the industry, and it's like for this sanding job, I would say it's probably the better tool than just the camera, because we saw even after it sanded, there was streaks left. So you can't really see that. You kind of have to feel it. Do you see this as being more challenging? And should we start with something easier before we maybe address the tactile feedback for robots?
Yeah, so it's a fair point in tactile feedback, like things like if you're thinking what you might feel with your hand when you rub it over a part like that, that is incredibly difficult, which is why you saw that a person came in and did that part. And you know, if you kind of dig into +1's background and my background, we really do believe that robots can't solve all those problems. And if we recognize that, hey, that tactile piece is a hard problem, it's one that people know how to solve relatively easily, but one that robots are going to struggle with, that's when we bring in people to augment the robots. So that's why you saw what you saw in the person marking it off and that kind of thing. There's still work to be done, but I think from a tactile perspective, I don't see that happening anytime soon and being fully automated.
Cool, interesting. All right, thank you.
You.
All right, that was it for the questions so far.
Okay. All right, I'm going to go to my call to action. So I have a great audience, lots of capable people in here. You know, I like to end every application or every presentation with you know, what's the call to action? What needs to be done? So I'm a huge open source advocate. I think open source can do amazing things. We've seen it do amazing things with web technologies, and we've witnessed amazing things in robotics in particular. And so where it hasn't had as much impact is manufacturing in general, right? Manufacturers will still pay tens of thousands of dollars for software that really isn't that good, isn't really that complex, and maybe already has an existing open source alternative, right? And even if they wouldn't use the open source alternative, perhaps that open source alternative could drive some of those prices down and you know, make it more available to manufacturing. So I thought about this group, and Hans, you point out that Industry 4.0 and IoT, those are the same things, right? Except Industry 4.0 is maybe what we thought, in our manufacturing world, in our very little world. Yeah, we could do some amazing things. But again, like I said, we in manufacturing, we benefit by the technologies that work at much larger scales. And I believe IoT is that. So, we can fulfill the vision of Industrial 4.0 if we just leveraged the scale of the Internet of Things and all the things that are going on there. But here's the tricky part. People like myself who aren't IoT experts, we're not going to know what to bring to bear. So we really need people from the IoT space to come in and tell us in the manufacturing world what's available, what needs to be done, right? And I think creating a open source manufacturing organization where that is one of its purposes would be really amazing. So I believe this is a really good idea. I believe it can have 10 times the impact on manufacturing that ROS had on robotics, just in terms of scale. I think it's exciting to think about things like this. And if you're excited by this, I definitely want to hear from you. And but like I said, this isn't going to come from me because I'm not the IoT person. It's going to be somebody in this audience that really understands, how to push this forward.
Yeah, no, so I mean, this is actually one of the reasons why we've been doing the meetups focused on open source, right? Linux Foundation has a whole bunch of projects that allow you to do all kinds of things, and it's all open source.
Yep.
Some of it's quite mature as platforms, for example, EdgeX Foundry. And along these lines, so I can't talk about it a lot right now, but we're working with a big German company to try and figure out this part of it. And we'll hopefully be making an announcement here in Q2 along these lines of democratizing. And one of the drivers for this is, in the US, we talk a lot about manufacturers, and typically, when you think of a manufacturer, you think of Boeing, you think of Ford, you think of the very big guys. But the reality is, in the US, 98% of manufacturers, yes, 98% are 500 employees or less. 75% have 20 employees or less. The only way they're going to be able to adopt this if there's a lot of open source in the technology that they're using, right? And so, no, it's totally spot on. And yes, if you're interested in getting involved, let's chat as well.
Awesome. All right, I got one more slide. This is the self-serving slide, right? Shameless self-promotion.
Yeah.
We're hiring. The info's up there, but I also include some important links. I hope this was informative, and maybe
I think Shaun is, so Shaun's going to hang around.
Yep.
So the tables will only take up to 8 people. So if there's interest in more robotics, I'll label another table here for robotics. So if you guys want to chat, we'll figure out how to manage that. But again, thank you, Shaun. Thank you for the time. I'm glad you're okay with everything that's going on in Texas. You have power and internet. What else do you need?
That's basically it.
Oh wait, there's a question here. Alfredo. Okay, let's see if I can bring Alfredo onto the stage. No. Okay. I guess I'll ask the question. Is there any case where OnePlus Robotics adapted ROS to industrial processes using Siemens as PLC?
So we have not done that at Plus One Robotics. In my work at Southwest Research Institute, we did quite a few interfacing with PLCs. In that case, we almost always create a bridge. The PLCs speak a lot of industrial networking protocols. So we almost always create a bridge between that protocol and ROS. It's not hard to do. It's just hard to do generically, which is why you don't see a lot of support for it in the libraries.
Okay, cool. So that was it. I think that was the last question. Oh, great. All right, this will be the last question, and then if you want to hang around and ask the question at the table. So I'll bring. Hello. Go ahead.
Hi. Thanks, Shaun. That was great. I typed in my question, but I forgot to post it. So I was wondering, you're a big advocate of open source. I was wondering if you've encountered much resistance to, end users of automation when it comes to introducing the idea of open source projects. And I guess I'll say that the limited experience that I've had with that is that they typically tend to be fairly reluctant and see open source as a liability.
Yep. So I would, when we started the ROS-Industrial and the ROS-Industrial Consortium, I would say that was the predominant viewpoint. Everybody felt that way. And so one of the reasons we started ROS-Industrial, here's the dirty secret about ROS-Industrial. In the very beginning, it was ROS. Even to this day, the core of it is ROS. We've added a lot of capabilities on top. We try to talk about what you can do with it, but ROS is the core of it. And we knew that would always be the case. So we knew we had to get people to accept open source if it was ever going to happen. In the beginning, what we did is we found applications that you could not do without open source, right? And we found champions within the companies that were supporting ROS-Industrial, and they would kind of fight the internal fight for us. And then after a while, we started to find that, we could say, well, Boeing uses ROS. And then, the conversations would end pretty quickly. And so one of the things that the ROS-Industrial Consortium and the companies that support it is that, they're being very public of their support for ROS. And that gives you enough credibility to get over some of those hurdles. But not all of them. Sometimes it doesn't work out. And, I've learned that sometimes you just got to cut and run from those kinds of applications. But way better than it was. That's the positive spin on it.
All right, software will keep improving, right?
Yep.
Yeah. But so it already does a lot more than just starting from scratch. So, yeah, great question.
Yeah.
Thanks, Shaun.
Thank you.
Thank you.
All right, so I am going to end the session here.